So to continue off the spiel that I talked about concerning data, it's very important for you to understand why data is so important. So here's a very, very basic example. Please take a look at my graph on the left. Judging from this picture, what would you say, what can you say about the trend or the correlation between X and Y? What's the correlation? What's the relationship? Yes. Positive. Explain. As X gets bigger, Y gets bigger. Correct. As X gets bigger, it appears that Y gets bigger. So you, maybe you can say that this is my trend. Something like that, right? Having an equal amount of dots above and below the line of best fit. And I know that you understand this because we just did a unit on it. Now, here's the part where why at this point, I don't want you to be using this squiggly line on the y-axis. And this is why, because data, you can make data say anything you want. If you were true to the data, let's open this up. Instead of giving you a screenshot of these 1, 2, 3, 4, 5, 6 points, right? I lengthen this, and then I make this all the way down to 0. What if that data was actually just a screenshot of this? What would you say the line of best fit would be here? It looks more horizontal, doesn't it? So in other words, if I were to lie about my data and only give you this portion, yeah, I can say whatever I want. So this example gives you 2 different points. Number 1, you need to consider more than 6 points, right? You need to have a large sample size to tell the truth, right? Case in point, Elon Musk. I'll get to it in just a second. Did you hear what Elon Musk was doing to Twitter? What he tweeted over the weekend? So a long time ago. Pardon? Well, that was a bit ago. Recently, I love the fact that it overlaps with today. Recently, he got flagged by the previous owners of Twitter saying you violated NDA rules, right? You basically revealed confidential information. But here's the confidential information. Twitter, a long time ago, was flagged for the number of bots, the number of automated accounts, where it wasn't really people, but Twitter was like, oh no, it's full of real users. And that's how they invited advertisers. Right? So if Twitter, with like 5 billion people on it, if 95% of the users are real, right? Think of how many people you reach from a single tweet. Does that make sense? That's a lot of people you can advertise to. But interestingly enough, guess how Twitter got that number of 90% of real numbers and 10% bots? They took a sample size of 100 people. So out of a sample size of 100 people, 9 people were real and 1 person was a bot. And so they got, so 90 people were real and 10 were bots. So like, oh, 90 out of 100, that's 90%. 90% of my 5 billion follower, whatever, are real people. And turns out that wasn't true. And so Elon Musk, who's now revealing these things, are getting flagged. Yes? Yes, but I'm hoping that 9 out of 10 is because they interviewed like 1,000 dentists or 10,000 dentists. They didn't just interview 9 dentists or 10 dentists, right? Yes.
What does this really line?
It means that the axis must start from 0, but my real data begins at 98. So let's go from 0 and jump to 98. But in doing so, this little narrow space from 98 to 101 is stretched. So it looks like there's a huge change, but it's actually a change of 1 or a change of 2. Data is so important. And the more you learn about data and numbers and math in general, the more you become a better critic of numbers. You become a better arguer of whether something is true or not. And so I hope that you would appreciate the data. The second thing that you might get from data in this particular case, I forget. There's something else I wanted to say, but let's move on. I think you get the point. Okay. Shameless plug. Stop doing this. Okay. Stop doing this. Yes. Never. Because it can skew your understanding, skew your findings. Okay. So don't do that. All right. Let's move on. We are talking about the first thing we're going to talk about is quartiles. Quartiles. What do you think the root Greek Latin word for quartiles is? Take a big guess. Someone? Yes? Groups of four. Or quarters, right? Yeah, absolutely. Number four, quartile. So we're going to take data and you're going to learn how we can organize groups or data into groups of four, or into four groups rather. And you'll see how that can actually tell you a lot more about what we're looking at. Looking at a bunch of numbers doesn't really speak out to a lot of people. So let's gain some experience of how we can make it speak out to us. Here we go. The table shows the countries with the highest carbon dioxide emissions in 2019, as well as their carbon dioxide emissions per capita. Use the data in the table to answer the questions. So I'm going to start by doing this, and I'm going to constantly go back and forth and back and forth and back and forth, because everything we do will be based on this second column right here by country, MT. Okay, that's megatons, by the way. Here we go. Right? If you want to, step one, this is super important, super important, so important. So important. If you want to start organizing this data into quarters, the first thing we need to do is write the entire data from lowest to highest. Otherwise, there's no way we can make sense of it, at least with our understanding right now. So it would be nice if we had Google Excel or Microsoft Excel or Google Spreadsheets, but we don't. So I'm going to ask you to painstakingly write all of this in smallest to largest. So least to greatest. So look through the list. It is in order. Yeah, that's a hint, but it's obviously reversed. So I'm going to write it on the left side here. Okay, so you can write it here. It's 479 first, and then comes 577. And then, okay, I'm going to write it in smaller numbers because it's going to. But yes, I did it on purpose so that we can save time. I don't want everyone to, if the numbers are not in order like this, you have to do it carefully. But for our purposes, yes, I made it nice so that the smallest number is on the bottom. So I'd like you to write it as 479, and then 577, 582, 611, 618. Yep. I'm annoying that way. And if you can, if you have small enough writing, see if you could write it all in a single line. Yes, Nate? Nate, question? Nothing really, but you're gonna have to do some interpretation, because I will ask you what's the largest quarter, what's the smallest quarter. So you're gonna have to flip it in your head. Okay, so please note, I simply rewrote this and these numbers are going to follow me everywhere. I hope that you will, humor me with that. Okay. Data. As annoying as it is, and again, this is, in my opinion, this is the field of math I hate the most, if I had to choose, because it's very detail oriented and I find it annoying. But I still appreciate what it can do for us. And in fact, there is a field in statistics that's so high profile that to get there requires like exam upon exam upon exam upon exam, like 8, 9 different exams and back to back to back. But once you're there, you are so coveted because no one else can do what you do with an easy like $500,000 a year, just because you're able to analyze numbers that other people cannot. Okay. Okay, not everyone gets that. It's a select few, but you get what I'm saying. All right, writing this data from lowest to highest. In the set of data, identify which one's the largest and which one's the lowest. Very important. Write that down. Max, in this case, will be, yes. Okay, and then do the min. Okay. Why is that important? It lets us discuss one particular aspect of data, the range. What is the spread? Okay, if anyone here follows a lot of like sports statistics, right? Or you're listening to a game, sometimes you might hear someone say, oh, like a basketball game, what's the spread? What do you think that means? It's a basketball finals, right? And the score is going up, going up, going up. And someone had to go to the washroom for a very long time because they had stomach problems and they come back like, what's the spread? What does that mean? Yep. It is the score, but they want to know what the difference between the two teams are. What's the spread, right? It was like, oh, they're down by 6 points. That would be the correct answer. You get what I'm saying? That's spread. So it's sort of like saying range. Yes. Right. So there's a couple of ways we could talk about it. Yeah. So right now, we'll talk about the range as the difference between max and min. That would be, as you said, did you already do the math for me?
Yeah, 9,006.
96. Okay. Let me just confirm quartile range. Yeah, okay, so that'll be the max range. Next, do you remember in elementary school, you were probably asked to learn how to calculate mean,
Yes.
median, and mode? Okay, the mean, I will remind you how to do that if you forgot. I want to focus on the median. Okay, median. Median, by definition, anyone remember? We got two people. Maya? In your own words, someone else. We got two people constantly. What the heck is med? Got it? Correct. Whatever the range is, whatever the number data is, I want to find the one right in the middle. Okay, so let's go down, going down, going down, going down, going down. Same data set, but I'm going to erase the max and min. What is the median of the CO2 emissions by country? And by definition, the median, sometimes called Q2, and we'll get to that, divides an ordered set of data into an upper half and a lower half. So determine the middle value of this. Let's count. I have one data set, one data, two data, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, take a look. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The middle is right here. Determine the middle values of this data set. It would be 702 and 780. So what is the median? It can't be both. You got it. You got two people. Back to Ellie.
Would it be the
Oh, so gross. Think of it as marks. If that was a mark on your in your tests,
Oh,
you're calculating the average. If you have two numbers, so in other words, there is no middle number, there is no actual median in your data set, you create your median by calculating the average of the two other numbers. So that would be 702 plus 780 divided by 2. Thank you. That was fast. That comes, oh, no, careful, careful. Add them together. So it becomes 1482 divided by 2, 741. No, I think that's something else. So what you're doing for median, if there happens to be an odd number of data, you're looking for that middle number. That's your median. But if in this case, I have no middle number, we have two that share that middle position. So we are going to average it. Next, moving on. That is Q2. This is the second quartile, so to speak. Quartile number 2. Let's move down. The first quartile, look at the diagram, everyone. Now that we found the second quartile right here, I am looking for the number that is exactly a quarter of my data. So let me erase all this, all these dotted lines. I don't need it. From my dotted line 1 to 6, what is the middle data? Well, 1, 2, 3, 1, 2, 3. My dotted line is right here. There is no middle data between in the first half. So what do we do? Same thing we do every night. Maybe try to take over. Anyone have any idea what I'm saying? Do you know what I'm talking about? No? I'm so sad. Anyone heard the cartoon Pinky and the Brain? I'm so sorry. Okay, I'll just shut up. All right. So what is the first quartile? You do the exact same thing. You just assume my data set consists of the first half of numbers and tell me what that middle number is. It just so happens there is no middle number. Two different numbers share that position. And so my Q1 is going to be 582 and 611 averaged. So let me. Yep, it can happen. You will see hopefully by tomorrow. Right now, we're simply learning the mechanics of it, how to calculate it. And then once we start using this data and trying to draw visuals and represent things, I'm hoping you get a better appreciation, if not just a full understanding of why we do this. Okay, so the first quartile is 596.5. Would you please calculate for the third quartile as well? Using the first quartile, I think you can figure it out. The third quartile uses the second half of the data. And if you count it, you realize there is no number perfectly in between. And so you're gonna have to find a number in between by averaging the ones right next to it. So quartile number 3 is 1678, averaged with 26, 26. That's a 4, 1 goes up, that's a 0, 1 goes up, that's a 3, 1 goes up, that's a 4. 2152. 2152. All right, boys, put your phones away, please. In the back. Essentially bringing us to the last bit. Everyone, today's lesson is short in that I just need you to be able to talk about these pieces. If I give you a set of data, can you tell me what the max and min is? I hope so. Can you tell me what the full range is? I hope so. Can you tell me what the median is? And then the first quartile, and then the third quartile? In other words, can you tell me what number is on top of the first 25%? And then can you tell me what number is right in the middle, in the 50%? Can you tell me what's in the 75th%? And can you tell me who's standing on top at the 100%? Question.
So say our we didn't have this before, so it's only 11 years. Still split up by
So instead of trying to group things, so maybe we can do 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. We will do a practice question. So hold that thought, okay? In the next section with the quartiles practice, I'll demonstrate when we have an odd number of data. Maya, question?
Yeah, so basically what happens is that the numbers that are given in the set for the graph, and those numbers are what is by the quartile.
Yeah, essentially, right? It doesn't matter what the actual number is. I want to see how many people, or I want to see where I stand. I want to see which number is 25% higher than the lowest, right? Like in terms of numbers. So forget the actual score. Let me give you an example. Here's how they analyze statistics. I think I remember telling you the story of my math journey, and I took a test for UTS in grade 6 or grade 5. Do you remember that? And I found out my math was like lower than average. Did I tell you this story? Was it for science class only? Okay, quick story time. I don't mean to waste your time like this, but this is what they gave me as a report. That's why I think it's very applicable. In grade 5, excuse my language for the recording, but I thought I was a shit. Okay, when it comes to education, when it comes to math specifically. In the elementary school that I went to, I was always top of the class. Always. Right? All my friends would ask me for the questions. Right? All for help, for extra whatever. And then, thinking that I was good and my parents being encouraged and wanted me to go to like a stronger school, blah, 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 they got me to take the UTS entry test in grade 6. UTS is University of Toronto Schools. There's a couple of branches, but the most prominent one, I think, is downtown at the University of Toronto campus. It's for grade 6 to 8, and then high school 9 to 12, whatever. Anyways, they gave me back this. For English, I was and for math, I was. What does that mean? Forget the score. It's not about the score, right? Out of 100 people, if 100 10-year-olds took this test, I was above 53 of the students in English. But there were 46 other students who were above me. That's what percentile means. It has nothing to do with an actual grade. It means who got better than you. You know what I'm saying? Because if all of us got 99%, right? Shouldn't our score be 99th percentile? No, that's not true. Right? It has nothing to do with the score. It has everything to do with what number, who is above you, who is below. And 46th percentile with math there were more students above me than below me. And of course, I got angry about that, and I took that, my parents took it into their own hands and we ripped it up, right? All summer long, blood, sweat, and tears. All through university, high school. Suddenly I started taking math at university, and suddenly here I am, right? It's funny how life sort of takes you in funny places, but that's what percentile means. It has nothing to do with how well you did or how poorly you did. It has everything to do with how many data pieces are above you or below you. Right? Let's talk about this now. Interquartile range. And this is the last thing that we're going to talk about before we move on today. The interquartile range is the difference, in other words, the subtraction between the third quartile and the first quartile. Literally, take your Q3, take your Q1, and we subtract it, and we will figure out what the range is. So what was our Q3? Yep. 49. Okay. Okay. Interquartile range. So IQR is just a subtraction. And it gives you the spread of what is the distance or what is the volume, what is the number of numbers, okay, what's the spread between the 25th on the list and the 75th on the list. That's the spread, so to speak. Yes. Sure. 1,500. What? 52.5. Yeah, that's it. Okay, so I don't need you to. Okay, I don't need you to be too worried about why we're using this or where we're going to use this. I would like you to first be able to use it to calculate it in your own means. So if you take a look, I'm going to do a different set of data. I'm going to do an odd number of data for you. If you turn the page, look at the second table from the top. It starts with 52. Please take that data set and reorder it from lowest to highest. Let's do that right now. Let's see, that looks like. So Maddie, this is specifically for you because this has 1, 2, 3, 4, 5, 6, 7 data. It's odd. Okay, so here we go. Reordered, it is, let's see, 24, 36, 48, 52, 52, 60, and 72. All right. Well, yeah, the first one happens to have an even number, so I specifically chose this. All right, minimum 24, maximum 72. If you list it in order from lowest to highest, it makes it that much easier to analyze it. All right, range. Range. Let's see, 60, 58. So the full spread from the lowest to the highest, whether this could be marks on a test, this could be number of points in golf, I don't know, just random, okay? 58 is the spread from the lowest number to the highest number. From here, let's talk about the second quartile, quartile 2, AKA median. Oh, this?
Yeah.
Correct. My bad. Okay, so median. I'm going to number this as 1, 2, 3. You don't have to number this. This is just for me to show you 6 and 7. Clearly, there's an odd number. So if you're okay with even versus odd, I think you'll be able to quickly identify that there is a number that separates the bottom half with the top half. There's 3 to the left and 3 to the right. So the median is 52. Here's where certain websites, I think, say certain different things. The first quartile is not 24 to 48. You are going to include the median as your data set. Wait a minute. Maybe I'll, let me confirm. Let me confirm. It's been a little bit. So it is correct. It does include the median. The median is part of the lower half as well as the upper half. So the first quartile, I will highlight in, let's do red. This is the first quartile, which means quartile number 1 is going to be the average of these two. Why? Remember, I have 4 numbers in the first half. And so what's the middle number of the first half? It's got to be the average of these two. So I guess the main question to ask yourself is, what is the middle number? And if I can't figure out a middle number, then I have to calculate that middle number. So that would be that would be, of course, because you're averaging. First quartile is 42. Now let's do the rest in green. Once we have the first quartile done, we can talk about the third quartile. So we look at the upper half of the data, and I'm looking for the middle number of these 4 points, or these 4 data points, which means I'm going to have to calculate the average of 52 plus 60 divided by 2. That's 112 divided by 2. That's a 56. That's it. Interquartile range, IQR, which is 75%, the 75th percentile minus the 25th percentile. I want to see essentially what data sets are going to be within the majority of what's average, right? So it's 56 minus 42, we've got 14. The IQR is 14. And again, a shameless plug, what does that mean? Let's pretend this was test scores. Okay? Let's say it's like a math test. And 1, 2, 3, 4, 5, 6, 7. There are only 7 students in my class. What does the IQR stand for? What does it mean? This is what's powerful about the interquartile. It means 50% of my students scored within 14% of each other. My 25th student to my 75th percentile student, everyone in between consists of half of my class, correct? 25%. And all of them were within 14 points of each other. So these things, although it might seem like nothing, it says a lot to the person reading it, if they know how to read it properly. Okay? So my homework for you, we still have like a good 30 minutes. I think we did the entire sheet. Could you try finishing these quartile practices? The very last page has some more homework in the form of word questions, but there's no point in trying the word questions without knowing how to do all of this. So give it a shot. And if you have any questions, come and ask me, and then we will have